Okay, we're going to take a brief intermission from talking about circuits and electricity directly, and we're going to talk about magnetism, which is, incidentally, actually related to electricity, though not directly necessarily. So anyway, we'll get to the tie between these two shortly. But first, two quick videos about magnetism, and we're going to start with this one. I'm not going to spend a ton of time on this because I believe that most of you are already basically familiar with a lot of these concepts. You've been learning about magnets ever since you were little kids because they're so fun and everybody talks about them and you play with them and you push them around the table and so on and so forth. So magnets are fun, and you probably know a lot about them already, but we're going to get into some of the technical definitions and things like that in this video, and then we'll do a bit more in the next video. And then we'll be back to talking about electricity and tying magnetism in with electricity. So here we go. These are just several pictures of magnets. This is a basic bar magnet, basic horseshoe magnet, and then these are extremely powerful, very small magnets made from a material called neodymium. Neodymium, which is the most powerful magnetic material we have so far. Alright, so those are just some, get your mind in the swing of magnets. Alright, so let's talk about what things are magnetic and what things are not. And again, you probably already know this, but in any case, here are some steel girders being hooked together for the frame of a building. Magnetic or not? Yep, those are magnetic. How about paper? A stack of paper. Magnetic or not magnetic? Yeah, not magnetic. You know that already. This one you might not know what that is. That is little bits of iron. Iron metal. Magnetic or not? Yes, that's magnetic. Here we have some bits of plastic beads. Are those magnetic or not? They are not. And then here we have several pieces of things that are attached to magnets, and a bunch of magnets as well. These are all ceramic magnets that you might use for like sticking something to your fridge. You'll notice screws, little hairpin, a hook thing here, a little bolt. All the things that are attracted to magnets, almost all of them anyway, have one thing in common, and that's that they're either iron or steel. And incidentally, steel is made from iron. So basically, iron is magnetic. And there's a specific word for this, which I'll write out right now. And that word is ferrous. Ferrous. A material is magnetic, that is magnetic, is called a ferrous material. And this comes from the, I believe, Latin word for iron, which basically involves this, I don't actually know what the word is, but it starts with F-E-R. So this prefix refers to iron, ferrous, like iron. Alright? Anyways, moving on. Alright, so I said iron and steel are basically the two common things that are magnetic, but there's a difference. Alright, so here we have the picture of iron bits and the picture of steel girders, just to keep those in mind. But they make magnets in different ways from each other. Alright, basically if you get steel magnetized, it stays magnetic. Alright, unless some other thing affects it, it will remain magnetic. Basically permanently, but it's semi-permanent because you can mess with it and change it around. It's not like once you make a steel magnet, you can't ever change it. You can change it, but basically unless you influence it with another magnet later, it's going to stay magnetic. Alright, so what kind of thing will that make? That basically, you can use steel to make bar magnets like this, and in fact this one would be steel, I believe. It's just painted. Painted steel. And they've used some other permanent magnet to create this magnet, alright, out of steel. So then what's iron used for? Iron will attract to magnets, but as soon as you take it out of the magnetic influence, it will lose its magnetic properties. It is not permanent. It's a very non-permanent magnet. So what do we use that for? Well, that means that we use iron whoops, for electromagnets. Basically, when you want to use electricity to make a magnet and you want it to turn off when you're done, you need to use iron. If you did this with steel, if you did this same thing with a steel instead of iron, you'd basically make a magnet and then you'd turn it off and it would stay magnetized and everything would stay stuck to it, and that's no good, right? So an electromagnet, you use iron as the core. So summary, iron makes a temporary magnet. It's a temporary magnetism. It's called soft magnet. And then steel is a permanent magnet or a semi-permanent. And it's called hard because it stays magnetic. Iron does not stay magnetic, so it's called soft. All right? Cool. Now just a little bit about lines of force. Every magnet has around it what's called magnetic lines of force. And it looks a bit like this, drawn out. I'm sure you've seen these kinds of things before. And this is the direction of force that would be experienced by a magnetic material in the influence of this magnet. So if you put a piece of iron here, it would go to the South Pole. Actually, this is a little bit misleading because if you put a piece of iron over here, it would go to the North Pole. But you have to draw the arrows one direction or another, so the convention is that you draw the arrows coming out from north and going into south, right? So if I were to bring another magnet in here, the lines of force would be altered by the interactions with the other magnet. All right, we'll look at that in a minute. How do you find the lines of force? Well, there's two methods. You could use iron filings, and those would just show you the shape of the magnetic field, as you can see here in this image. These are iron filings, and you can see how they line up along the lines of force. They make these bands that go from north to south, loops, and they kind of get more like wider. But all these lines of force would loop around eventually to the other end of the magnet. All right, I just did that wrong. I should go from north to south. Anyways, but this doesn't tell us anything about, you know, the directionality of the magnet unless we already happen to have them labeled conveniently. So what can we use to find the direction? Well, we can use what's called plotting compasses. So these are compasses where the red end is north. And of course, as you know, opposites attract. So the north end of the compass is going to be attracted to a south pole of a permanent magnet. And incidentally, the little needle in the compass, that's also a permanent magnet that's free to rotate. So if you were to line up a bunch of plotting compasses maybe on a piece of paper with this guy in place right there, then the lines of force will be shown by which direction the needle of the compass points at different points on the paper. So you can see how here we've got sort of a loop that goes around from one side to the other. And if you started your little loop maybe a little bit closer to the middle, you'd get a smaller loop, maybe like this. Obviously, if you went over on this side, the loop would go a bit like that. So you can use these plotting compasses to show you the lines of force as well. All right, and then just to one last little bit of information, and that's that magnetic forces between magnetic materials are caused by interactions with the magnetic field. So that's pictured here. If you bring a north pole near a south pole, and these are both permanent magnets, then you can see the lines of force sort of combine, and you get this is a very strong, well, not necessarily strong, but a pretty strong interaction between these two magnets here. So these two are going to want to slide towards each other. All right, they're going to experience a force towards each other. If I did this the other direction, they would repel. The lines of force would push away from each other, and they would prevent them from getting close. So magnetic force is caused by interactions between magnetic fields. All right, that's enough for this video. We'll move on to the next video. All right, thanks for watching, and see you next time.